Hey there guys and gals, and welcome once again to the D4E channel. Now, I'm really excited about today's video. Why? Because today we're talking all about my upcoming bike carb conversion. Now, this video is actually going to contain my whole plan, which is going to be the baseline. It's going to, contain the fundamentals of how we plan to do the bike carb conversion on my engine. Now, it's going to contain all the parts that you need. I'm going to list the specific parts I'm ordering. It's also going to address all the aspects of the bike carb conversion, such as ignition, fuel delivery, carb tuning, and so on. So in the end, this video may turn out to be kind of long, but I promise it's going to be super useful and full of really useful information. So we don't get lost in all that information, I'm actually going to put up a big piece of paper here so I can write down, the important things that we need to cover and address to make this a good, useful video that's going to be a reference, for the rest of the build. Okay, now I know this looks like a lot of information, but don't be scared. It's a lot simpler than it looks, and we're gonna go step by step through all of this, so we're gonna cover everything and it's all gonna make sense in the end. Now, first thing, the plan. The plan is actually 4AG on bike carbs and stock ECU. And then later, I'm going to move to a standalone ignition controller, something like NSD. Now, you're saying, why do you need an ECU if you're running carbs? Well, before, cars used to have a vacuum advance line running to the distributor, and that was doing the ignition advance at higher RPMs. 4AG is electronically fuel injected. There is no vacuum advance running to the distributor. The ECU controls the distributor, so you need to keep the ECU, and you need to keep all of these inputs that the ECU needs to run the distributor properly and create the ignition advance at higher RPMs. So that's covered. Before I start talking about all of this, I want to talk about why. Why would you mod a car engine that's fuel injected to run on carbs? Now, don't be mistaken, I'm not the first guy doing this. There's a lot of guys who have done this before, and there's a couple of reasons why you would do it. Now, number one is sound. The 4AG sounds nice as it is. The 4AG on carbs sounds even better. In general, car engines running on carburetors, to me, sound really nice. Look it up. Number two is the looks. Now, the 4AG has one throttle body, and that's okay. But imagine the 4AG, you've probably seen it, with individual throttle bodies. Bike carbs have one throttle body for one cylinder, so that's 4 throttle bodies, 4 intake tubes, and it's all made to look right. It's really cool looking. Number 3 is responsiveness. The 4AG and any car engine on motorcycle carbs, and I think carbs in general, when tuned right, is actually more responsive than fuel injection. Now, there are definitely exceptions to this, depending on the engine, but in the case of 4AG, if you do it right, if you tune it right, it's actually going to be the throttle response is going to be better on the carbs, if you tune it right. And I really do like a responsive, revvy, naturally aspirated engine that you don't have to drive really hard to get the most out of it, and feel engaged while you're driving it. So that's that. Reason number 4 is actually power gains. There is some power to be made from bike carbs. If you're lucky, you can make like 15, maybe 20 horsepower if you're super lucky and everything else works right and you tune the carbs properly. Another thing that should be covered is, why would you install bike carbs instead of something more traditional in terms of carburetors, like let's say the twin Weber carburetors that you can see on a bunch of 4AGs? Well, there's a couple reasons for that too. Bike carbs are cheaper. A set of twin Webers nowadays costs a small fortune. A set of bike carbs is like $150 used. There's a lot of them. That's number 1. Number 2, actually, bike carbs are easier to tune. They have better MPG, and they're even more responsive when tuned right. And they're actually even more reliable when tuned well. So that's on the side of the bike carbs. Now, let's see the negatives of the carbs in general. Now, there are some negatives, definitely. Number one is, if the car you're thinking about converting to bike carbs is your daily driver, I'm gonna have to say no. Because converting fuel injection to bike carbs means that you are losing the rock solid reliability of fuel injection. Fuel injectors are actually simple and reliable, and when compared to carbs, they do not need any tuning and fiddling. Now, carbs do not fail, they do not need to be replaced, but they need to be fiddled with and tuned from time to time. And sometimes the little gaskets need to be changed, and the jetting needs to be readjusted and whatnot. So if it's your daily driver, I mean, it's a hassle maybe you do not need. Also, if it's your daily driver, your MPG is going to be worse than with fuel injection. Of course, fuel injection is more efficient. It's a more modern concept. And so the MPG with fuel injection is always going to be better. You can have the world's greatest carb tuner, tune your carbs. Your car with the stock factory fuel injection is going to be more fuel efficient. End of story. So that's the why part. Now let's talk about parts. Okay, so here's all the parts we're going to need. Let's go through all of them. Obviously, you need the bike carbs. Now, if you look around bike carb conversions, you'll see that a lot of people are using Yamaha R1 carbs. Those carbs are too big for the 4AG, so I'll be using 600cc motorcycle engine carbs that have been shown to flow better on smaller inline 4 engines such as the 4AG. You need an intake manifold. Once you go to the carbs, this whole thing, the 4AG intake chunk manifold, is gone. And because obviously bike carbs aren't made to fit to the 4AG engine, you need something to fit them there. You have two options. You can fabricate this yourself, or you can get it made. Number 3, you need an air filter. Obviously your stock air filter is gone with your intake manifold, so you need an air filter over the carbs so they wouldn't suck in little kids from the side of the road into your engine. You need a fuel pump. Your stock electronic fuel injection, fuel pump is high pressure. Carbs need a low pressure. We'll address this later. You need an intake manifold gasket. Obviously, you're not using the stock intake manifold anymore, so you need a different gasket. You need silicone hoses. You need silicone hoses between the bike carbs and the new intake manifold. These need to be fluoro-lined, which is a special material that's going to prevent the silicone deteriorating from all the fuel that the carbs are bringing into the engine. You need a vacuum balancing bar. I'm going to ignore all of this. I'm going to explain it later. And I'm going to stop here. Now, all of these parts, you can try sourcing yourself, looking around, going to these junkyards or the internet, finding used bike carbs, and then cleaning them, jetting them, whatever, inspecting them, getting, seeing if they flow right. Then you can get an intake manifold, you can get a welder, you maybe already have it, maybe you know how to weld, then you can weld it together, then you can get an air filter, and you need a base plate, and then you need to make the base plate, fit to your particular bike carbs. Then you need to find a fuel pump, and then you need to cut out the intake manifold gasket out of your gasket material, and so on and so forth. And you are going to do all of this with the illusion that you are going to save some money by doing it yourself. Now, I have actually done some research, and I have looked around and done some calculations, and by doing all of this yourself, you are going to save I think $50 or maybe 75 if you're super lucky. So what I did, I found a company in the UK called danST Engineering that makes all of these things and ensures they fit right and they work right, and they specialize in bike carb conversions. So by actually getting all of these things, all of these things from one place, you ensure it's all going to fit properly and work right, and it's compatible with each other. So what I'm getting, first of all, the intake manifold danST Engineering makes is a TIG welded, aluminum intake manifold that looks beautiful. If you look at intake manifolds around the web, you know that people have fabricated themselves, DIY guys. I have to be honest, they are not pretty. And the whole point of doing this, one of the big reasons why I'm doing this is to have it look beautiful. So I'm getting this made by a professional and having it look beautiful. The air filter, I'm getting a Piper Cross, I think PX500 air filter that has a base plate that danST engineering makes that fits perfectly to the bike carb, so it ensures, even more nice fitment, compatibility, making it all look, representative, I guess, show car things. There's also an intake manifold gasket. It's a high quality intake manifold gasket. Again, that's not cut, by a guy with scissors. It's actually, again, fits perfectly to the intake manifold. I'm getting a fuel pump, which is actually a motorcycle fuel pump, but again, I'm going to explain this later. And the silicone hoses also come together, this whole thing actually is a kit that the company makes, and it all works really nice together. Moving on, what else do we need? We need a lightweight crankshaft pulley, and we need injector plugs. Why do we need this? Well, as I said, in the future, I plan to move to standalone ignition. You don't have a standalone ignition controller, and for that to run, you need a crankshaft position sensor. The 4AG, as stock, does not have a crankshaft position sensor. So you make one. How do you make one? By getting a crankshaft pulley with a trigger wheel on it. Now, a company called Techno Toy Tuning actually makes a beautiful crankshaft pulley that's super light, that's perfectly balanced, and they also make a trigger wheel that you can easily attach to this crankshaft pulley, and also the price of all this is pretty nice and attractive. So I'm getting two things by this. I'm getting my engine to look nicer, and I'm also, reducing the rotational mass of my engine, which means the engine is going to spin more freely. And in the future, when I go to standalone, I'll actually be able to, get a trigger wheel from Techno Toy Tuning and then just easily attach it and make a crankshaft position sensor. Injector plugs. Why do you need this? Well, the injector plugs, in the case of the 4AG, are actually, installed, attached in the head, in the cylinder head of the 4AG engine. There's actually holes in the cylinder head of the 4AG. Let me get the cylinder. Nah, it's too heavy and big and bulky, forget it. Now, the cylinder head actually has holes, and inside these holes, the injectors, go into these holes. Now, once you remove injectors, obviously, since we're going with carbs, there's no more injectors, you have these 4 gaping holes that are going to be the biggest vacuum leak ever. So you need injector plugs. Again, Techno Toy Tuning makes really nice injector plugs that go there, you simply attach them, and it's all done. You will see some people choose to get these little freeze plugs, interference fit freeze plugs, and hammer them into their cylinder head. I think this is a pain in the ass because removing them is really complicated. You can actually damage your cylinder head. The injector plugs from Techno Toy Tuning are super easy to install and super easy to remove. All you need is, I think, 2 fingers. So someday, if you decide you hate the carbs and you want to go, let's say, with a turbo or something, you simply remove the injector plugs and put your injectors back in. Okay, so moving on some more. Another thing we are going to need to do to make the most out of our carbs is to tune our carbs, and we need to tune our carbs properly. To tune our carbs properly, we need a wideband air-fuel ratio gauge. Now, if somebody tells you they can tune their carbs by ear or by using their magical butt dyno, they're crazy, ignore them. Now, I did actually a lot of research to decide which wideband air-fuel ratio gauge to buy, because there's a lot of competition and there's a lot of different options out there. Now, after my research, I decided to go with the AEM X Series Uego wideband air-fuel ratio gauge. Why? Because AEM is a company that has been out there, for quite a while. They have done their homework when it comes to, research and development, and actually independent tests show that the X Series Uego wideband gauge is the fastest responding among its competitors. Now, you want fast response because that enables you to tune your carbs more accurately and make your engine perform better. So when it comes to carb tuning, I do not want to take any chances, and I have decided now to go with the best. So more when it comes to parts, here you can see it's map harness, map ECU, and map sensor. Why did I put this here? I put this here because my engine, my 4AG, in its stock form uses an airflow meter. Now, an airflow meter is a big part with a flap in it, and the flow of the air, moves the flap and tells the ECU how much air is coming into the engine. Based on this information, the ECU then does a lot of other things, including injecting fuel, advancing timing, and so on and so forth. An ECU, my ECU and my engine as such, cannot be converted to run on carbs, because once you remove the airflow meter, you cannot make the engine run in any way. So what I need to do is to convert to a MAP sensor instead of an airflow sensor. And what MAP is manifold absolute pressure. And compared to an airflow sensor, a MAP sensor is much smaller, and it actually is not restrictive like an airflow sensor. Actually, an airflow meter, sorry. Now, to do that, I will need to buy a MAP sensor, a MAP ECU, and a MAP harness. So I'm going to, since this is a 30-year-old car, that of course does not exist new anymore, nobody makes these things, so I'm going to buy this used, and I'm going to get it to work with the rest of these parts on this list. So now, that's when it comes to parts. In the description of this video, I have listed the links to each of these parts, so you can find all of these parts online, you can check the pricing and everything else. You can see how to order them and so on. It's all in the description. So, as I said, that's it when it comes to parts. Now I'm going to show you how we're going to get these parts, working together and have our Bike Carb 4AG running. Okay, some more confusion here. Now again, don't be afraid, it's simpler than it looks. So there's three main things we need to worry about, when we want to make our fuel-injected engine run on bike carbs. Those three things are ignition, fuel delivery, and carb tuning. Now, let's talk about ignition first. As I said, a fuel-injected engine, the distributor in a fuel-injected engine does not have vacuum advance. So we need the ECU to keep running the distributor. And to keep running the distributor and provide ignition advance at higher RPMs, the ECU needs signals from certain sensors in the engine. The most important is MAP, which is, as I said, manifold absolute pressure, and it's actually a vacuum sensor. What it uses, the ECU, by sensing the vacuum, is sensing how much air is coming into the engine, and based on that, does its ECU magic. Now, since the intake manifold is gone, we need to put we need a connection for the manifold, for the MAP sensor. Now, if you take the intake manifold is actually going to have 4 runners, 1 runner for each cylinder and throttle body. Now, if you tap 1 runner and put the vacuum hose for the MAP sensor in just 1 runner, you are going to have a pulsing signal. There's going to be pulse in your signal, and that is not going to work right. So what you need to do is you need to create a balanced vacuum. And danST Engineering has a product for that is made specifically to work properly with MAP censored engines. And what it does is it taps into each of the intake manifold runners and then takes 4 of these vacuum hoses into a single vacuum balancing bar, and then from that vacuum balancing bar takes the vacuum to the MAP sensor. And this provides an accurate signal for your ECU to run the distributor properly. Now, this is very important. Another thing that's also important not to forget when it comes to the intake manifold is to create a tap for your vacuum for your brake booster, because if you do not do that, your brakes are going to be rock hard and braking with your car is going to be, let's say, uncomfortable. So also think about that when thinking about your intake manifold. Now, number 2 is the throttle position sensor. Now, sometimes depending on the particular engine, this may or may not be needed. The throttle position sensor, what it does tell to the ECU is where the throttle is, and based on that, the ECU injects fuel. Now, since now it will not be injecting fuel, you might think that we do not care about the throttle position sensor, but we actually do in the case of the 4AG, because the throttle position sensor does have 2 particular things that it tells the ECU for the distributor, and that is when the engine is idling and when the throttle is actually has been opened. So how I'm going to solve this? I'm going to solve this by getting bike carbs that already have a throttle position sensor installed on them, and then I'm going to work to connect this to my wiring harness and to my ECU. Now, I have no idea yet specifically how I'm going to do this, and it might turn out to be a bit complicated, but I'm hoping I'll manage to make it work. And here we see stock ECU. As I already said, that's what runs the distributor, and that's all fine and dandy. Now, number two, what we need to think about is fuel delivery. Now, fuel delivery is very important. Here's why. The stock fuel pump in a fuel-injected engine is a high-pressure fuel pump. That means that the fuel pressure it generates, it's around, I think, 40-ish PSI. Correct me here if I'm wrong. I think it's around 40 PSI, maybe 38, I don't know. But the carbs, the bike carbs, and any carbs need a much, much lower fuel pressure to work properly. So the stock fuel pump needs either to be, the fuel pressure it generates either needs to be reduced, or the stock fuel pump needs to be removed. Now, modifying the pressure of the stock fuel pump or reducing it is actually it's a bit complicated. It needs a lot of hoses, and fuel lines. You need a fuel pressure regulator to lower the fuel pressure, and then some other things, and at the end it's still not very reliable, and sometimes the fuel pressure regulator fails and so on. So I have decided for a bit more extreme measure here to make sure my bike carbs get the exact fuel pressure they need, and that's going to be dropping my fuel tank, removing the fuel pump entirely, and installing a motorcycle fuel pump. Now again, danST Engineering provides fuel pumps that are perfectly compatible with the bike carbs they provide, so you can be sure this is going to work absolutely right. So that's it when it comes to the fuel delivery. Now, carb tuning. Carb tuning is very important. Carb tuning can actually make or break the whole build. You could have the best carbs, the best engine, the best everything, but if they're not tuned right, it's going to be horrible. Now, you can actually destroy an engine with improper carb tuning, because you can make the engine run very lean. That can create engine knock, and then you can kiss your internal engine assembly goodbye. Now, we do not want that. I said I'm not removing the engine again anytime soon. I'm tired. Now, so how we're going to tune the carbs? As I said, I'm using the AEM X Series wideband air fuel ratio gauge. And how that works is that it uses a Bosch, the newest technology, Bosch 4.9 O2 sensor. This is a wideband O2 sensor. And what you do is you weld a bung for the O2 sensor, you screw it in somewhere in your exhaust manifold, preferably somewhere after all of the 4 exhaust runners, to get data and exhaust gases from all of your 4 cylinders. You install it there, and then you run a wire to the gauge itself, and you run another wire to the gauge that gives power to the gauge, and you get your air fuel ratio readings. Now, carbs need to be tuned. There's a lot of jets, the pilot jet, the wide open throttle jet, and a bunch of jets. So you excuse me right now, I'm not very familiar with all of this, and I will need to learn actually. But what I do know is that the carbs need to be tuned at different, throttle positions. They need to be tuned at idle. They need to be tuned, when you open the throttle just a little bit, half throttle, and wide open throttle. This needs to be done right, otherwise the car will, as I said, perform poorly. Now, luckily, danST Engineering, what they do with their bike carbs, in addition to testing, and ultrasonically cleaning them and everything, they actually do offer jetting, so you can get your engine to run. Now, this is of course not going to be accurate. These are approximate jettings, so you can start your car and tune it. But you need the wideband gauge to determine, the perfect tune. Now, this little, initial approximate jetting is very important, because otherwise you would have to struggle yourself, to guess which jets, you need to actually just get the engine to fire up. So this is how we're going to tune the carbs. I'm thinking right now to just drive around the car, look at my AFR gauge, and determine, how to tune the carbs. But I'm also considering going on a dyno and doing this, on a dyno and hitting the spot with the perfect carb tune. So that's the whole plan for now. I know it looks kind of complicated, but I think this is what I can realistically do, what I can achieve, and having a nice, very responsive, great sounding, revvy, naturally aspirated engine is going to be a lot of fun to drive. Okay, this is definitely the most talking I have ever done in a video. But I think it was necessary to cover all of this and have it in one place so we know what's the plan. But I think I still managed, I hope I managed to keep this sufficiently simple so it's easy to understand. Now, as you have seen, I covered the parts that are going to be needed, and I covered what needs to be addressed to get this project on the road. I might have made some mistakes, so if I have done that, please feel free to correct me in the comments section. Also, if you have any questions at all, the comments section is all yours, and I will do my best to try and answer them. So as you have seen, these are the parts. I have honestly done a lot of research, to make sure I get what I think are the best parts for this particular, project. There's a lot of good things there. All the links for all the products are in the description, so definitely check them out. I think they're worthy of your attention. Also, I have ordered all of this, so it's all on the way, to me. It's somewhere in the mailing system now, but as these parts arrive, I will be doing unboxing videos on all of them. I'll also be reviewing them, so you have even more useful information when it comes to that segment. The plan, you have seen what we need to do here to get this running. And I think that's definitely enough for today. I need a glass of water. My mouth is super dry, so I'm gonna say the usual video ending stuff now. Definitely thanks a lot for watching. Don't forget to share, like, comment, and subscribe. Hit the little bell thing down there so you can get my videos, as they are published. I appreciate that. All of your support and attention to my channel is definitely a huge motivation for me, and it's helping me to make, ever better videos. So that's it. D4A signing out, and see you soon on the channel.